Hi guys, good morning. Welcome to this video lecture on replacement theory part 3. In the previous two videos, we have discussed about replacement of items that deteriorate gradually with and without considering time value of money. The optimum replacement periods were found by balancing the running costs against decreased depreciation. And in this video, we are going to discuss about group replacement theory, that is model 3 of replacement problem. There are certain items which do not deteriorate but fails completely after certain amount of use. These kinds of failure are analyzed by the method called as group replacement theory. Here, large numbers of items are failing at their average life expectancy. This kind of items may not have maintenance costs as such, but they fail suddenly without any prior warning. Also, in case of sudden breakdowns, immediate replacement may not be available. Few examples are fluorescent tubes, light bulbs, electronic chips, fuse, etc. Let us consider the example of street lights. We often see street lights being repaired by the corporation staff using extendable ladders. If a particular light is beyond repairs, then it is replaced. This kind of policy of replacement is called as replacement of items as and when they fail or individual replacement. On the other hand, if all the street lines in a particular cluster are replaced as and when they fail and also simultaneously in groups, then the policy is called as group replacement. Here, after certain period, it will be replaced irrespective of the fact that items have failed or not. It is found that replacing these random failing items simultaneously at specific intervals is economical as compared to replacing them only when an item fails. A long period of gap between group replacements results in increase in cost of individual replacements, while frequent group replacements are definitely costly. There lies the need to balance this and find an optimum replacement time for optimum cost of replacement. With an example, we'll see how we can use this group replacement theory. The following mortality rates have been observed for a certain type of light bulbs. There are 1000 bulbs in use. And if you are replacing it by using individual replacement policy, that is individual bulb whichever has burnt out, it cost rupees 10 to replace. If all the bulbs are replaced in group or simultaneously, it would cost rupees 2.50 per bulb. So it is proposed to replace all the bulbs at fixed intervals in group replacement and individually also those which fail in between the intervals. We have to determine which would be the best policy to adopt, that is purely individual replacement policy or a group replacement policy. And also we have to find out at what group replacement cost per bulb would a policy of strictly individual replacement become preferable. These are all the given data, that is percentage failing by month end is given for 5 months. For first month, that is at the end of the first month, there will be a 10% failure, and at the end of fourth month it will be 80%, and at the end of fifth month it is 100%. So from this, what we can infer is, it is very clear that no bulb will last after 5 months because it is given as 100% failure at the end of 5th month. First thing is we have to calculate the percentage failure during the month. Actually, the cumulative percentage failure up to the end of the month is given in the problem. Here, from this, we have to calculate percentage failure during the particular month. Here for the first month is given as 10. So, for the first month it is 10. Here up to the second month it is given as 25. So, in the second month it will be 25 minus 10. So, it is 15% during the second month. And the percentage failure during the third month will be 50 minus 25, which is 25. And percentage failure during the fourth month will be 80 minus 50, which is 30. And for the fifth month it is 100 minus 80, 20. So this is how we have to calculate the percentage of failure during the particular month. After calculating this, we have to calculate the probability that a new bulb shall fail during the particular month. So it is 10%, so it will be, the probability will be 0.10. And the same way for the fourth month it is 30%. So the probability will be 0.30. So we have to calculate all the probability like this. After calculating the probability of failure during the particular month, we have to calculate cost of individual replacement. So that is, we have to calculate the average individual replacement cost per month. The formula used to calculate this is number of units in operation divided by expected life of cost, that should be multiplied by cost of an individual replacement. We know this value, that is number of units in operation, which is given as 1000 bulbs, and we know the cost of an individual replacement, it is actually given as 10 rupees per bulb. And we have to calculate expected life of bulb if you want to calculate average individual replacement cost per month. How do you calculate this? The formula is given as, for the expected life of bulb, it is summation of xi into p of xi, where the xi is month and probability of xi is probability of failure during the particular month. So it is summation of xi into p of xi. So we can calculate it. That is, for first month it is 0.1. So 1 into 0.1. For the second month it is 0.15. So plus 2 into 0.15 and so on. So finally we will get 335. We know that cost of individual replacement is 10. So it is actually 3.35, not 335. So we can calculate average individual replacement cost per month as 1000 number of bulbs divided by 3.35 into cost of individual bulb as 10. So it comes rupees 2985. That is average individual replacement cost per month. Next we have to calculate group replacement cost. Then we have to compare these two, and whichever is lower is the preferable policy. To calculate the group replacement cost, we should know the expected number of failures of bulb in the particular month first. So for that, let we consider n suffix I as number of replacements made at the end of ith month. That is expected number of failure, of course. And we have 1000 bulbs initially. So at the 0th month, that is at the starting, it will be 1000 bulbs. During the first month, what will be the failure? We know the probability of failure during the month. What will be the failure? Yes, it is N0, which is initial bulbs, into probability of failure in the first month, which is P1. N0 into P1 will be the expected number of failure during the first month. So by using this, we can calculate the value, which is 1000. N0 is 1000, P1 is 0.10. So the expected number of failure during the first month is 100. So how do you calculate for the second month, that is N2? Think a while. You might be thinking like N0 into P2, right? It is actually not the case. It should be N0 into P2, it is correct, plus N1 into P1, because we have replaced this 100 bulbs during the first month itself as an individual replacement. So there will be some failure in this 100 bulb also. So it will be N0 into P2 plus N1 into P1. So this is actually the total failure during the second month. And for the third month, the same way it should be N0 into P3, that is for the initial bulbs. During the third month, there will be P3 failure, and that will be 100. This 100 bulbs will be replaced at the end of that month itself. So there will be failure of P2 in this amount, that is N1 into P2 plus after the end of second month, there will be a replacement of 160. In that bulbs, there will be a failure of P1. So it will be N0 into P3 plus N1 into P2 plus N2 into P1. So this is the calculated value. The same way we can calculate it for N4. For easy remembrance, what we can do is, if it is N3, we have to start with always N0, and we have to keep on increasing up to N2. This is before this number. N3 means N2, and the multiplication factor, that is P, should be, we have to start from this value. That is, if it is N3, we have to start from P3 and we have to decrease up to P1. So it is N0 P3 plus N1 P2 plus N2 P1. If you calculate it for the same way for the N4, it will be, we have to start from N0. So N0 into P4 plus N1 into P3 and so on. So N4 means P4. We have to start from N0, and N should be increased in the increased order, P should be in the decreased order. It is a shortest way of remembering this formula. Right? This is the calculated value for N4, and we have to calculate the N5 value also. What will be the N5 formula? Just think a while. Yes, it should start with N0 P5, right? N should be in the increasing order, P should be in the decreasing order. Yes, it is N0 P5 plus N1 P4 plus N2 P3 plus N3 P2 plus N4 P1. So this is the calculated value of number of failures at the end of, during that particular month. After calculating the expected number of failures by using these formula, we have to go for calculation of cost of group replacement. So by using this tabulation, we can calculate the cost of group replacement. This is at the end of 8th month. So we have 5 different months, so 1 to 5. Then we are just tabulating the bulbs failing during 8th month. What we have calculated just now by using this formula. So it is for the first month 100, for the second month 160 and so on. Then bulbs replaced until the particular month, that is cumulative value of the second column. So it is 100, 100 plus 160, 260, 260 plus 281, 541, 541 and so on. Then we have to calculate the cost of individual replacement, because the group replacement means it also involves individual replacement whenever there is a failure, and at frequent intervals or fixed intervals there will be a group replacement also, right? So we should have the cost of individual replacement. So for 100 bulbs it is 100 into 10,000 rupees, because the individual replacement cost of a bulb is 10 rupees. So for the second month it is 260 into 10, 2600. For the third month it is 541 into 10, 5410, and so on. Next is group replacement cost. We know that group replacement cost per bulb is 2.5 rupees. So 1000 bulbs we have to replace. So 1000 into 2.5 is 2500. For whenever we are replacing it, it costs this much rupees. Right? Now the total cost. Total cost means cost of individual replacement plus cost of group replacement. So 1000 plus 2500, which gives 3500. The same way we have to calculate for all the months. After calculating this, we have to calculate the average cost per month. This is the average cost per month, which is total cost divided by month. 3500 by 1, 5100 by 2, which is 2550, and so on. After calculating this, as usual, we have to choose the lowest value from the average cost per month, which gives the optimum replacement period. Here it is optimum group replacement period is end of second month, and the minimum cost, that is minimum average cost per month, is 2550. This is actually less as compared to individual replacement cost, which is 2985. So it is preferable to go for group replacement policy as optimal replacement policy. Next question is, we have to calculate at which group replacement policy cost the individual replacement policy becomes preferable. For that, we have to actually calculate the group replacement price per bulb. So we are just having X as that, and if the individual replacement policy should be preferable, this cost, that is the group replacement cost, should be greater than the individual replacement cost, that is 2985. So this 2985 should be less than the group replacement, the optimum group replacement cost. Optimum group replacement cost occurs at the end of second month. So we have taken that particular data. That is, this is actually the individual replacement cost for the second month. Here you can see that this is the individual replacement cost for the second month, and for the group replacement cost, it is 1000 into 2.5 for the previous case. For this case, we have to calculate that group replacement cost only. So it is 1000 into X, and it should be divided by 2 for getting the average cost. So that is why it is given here 1000 into X, which is to be determined, plus 2600 for the second month individual replacement cost, divided by 2 in order to determine, to get the average cost. So by having this relationship, we have to find out the X value like this. So the X value is 3.37. So this X value, that is this group replacement price, if it is greater than 3.37, this value will be lesser than the group replacement value. So the policy of strictly individual replacement becomes preferable. This is how we have to calculate the group replacement problems. Next comes an assignment problem. Here, mortality rate of a certain electronic component is given, and there are 10,000 items in operation. The group replacement cost is given as 35 rupees per item, and individual replacement cost is given as rupees 100 per item. By having this, you have to determine which replacement policy is best. That is, whether it is individual replacement policy or group replacement policy. Try this, and by this you might have learnt about the entire replacement theory. Hope you enjoy this video. Thank you.